In this video, we'll take a look at how to solve exponential and logarithmic equations. So let's take a look at exponential equations first. Whenever you have equations of the form, same base, b to the power of m equals b to the power of n, then if the bases are the same, then the powers must be equal to each other. So our first example, solve 5 to the power of 2x equals 5 to the power of 3x plus 2 have the same base, so the powers must be equal to each other. So we set 2x equal to 3x plus 2 and solve. Subtract 2x from both sides, we end up with x plus 2 is equal to 0. Subtract 2 from each side, x is equal to negative 2. The next example, the bases are not the same, so we have to rewrite so that they're the same base, if possible. So the left-hand side of the equation has 9 to the power of x, and the right-hand side has 1/27 to the power of 4x plus 5. 9 and 1/27 can both be written as a power of 3. 9 can be written as 3 squared to the power of x, which is going to end up being 3 to the power of 2x on the left-hand side, is equal to 1 over 27. Well, 27 is 3 to the third. 1 over 27 is 3 to the power of negative 3. So we have 3 to the power of negative 3 to the power of 4x plus 5. So that means it's going to equal 3 times 3 to the power of negative 3 times 4x plus 5. Now that we have each side written as a power of 3, we can set the powers equal to each other. So we set 2x equal to negative 3 times 4x plus 5, and then solve our equation for x. 2x is equal to negative 12x minus 15. Add 12x to both sides. We get 14x is equal to negative 15. Divide both sides by 14. X is equal to a negative 15 over 14. So that's solving exponential equations when using a technique where you can write each side to the same base and set the powers equal to each other. So that only happens in a few cases. Generally, what we're going to need to do is use logarithms to solve exponential equations, and that's what logarithms are going to help us do. So let me give an example, and then we'll solve. So for example, we know that 2 to the third is equal to 8, and we know that 2 to the fourth is equal to 16. But if we have 2 to what power is equal to a number in the middle, let's say 10, we need to have a way to find the power. So what we do is take the natural log on both sides of the equation for bases other than 10, take the common log on both sides for base 10. So if we have 2x to the power of x is equal to 10, what we can do then is take the natural log of each side. The natural log of 2 to the power of x is equal to the natural log of 10. Then we use that power property where that can rewrite x times the natural log of 2 equals the natural log of 10, and then divide both sides by the natural log of 2. From here, we put it in the calculator, natural log of 10 divided by the natural log of 2. So we have natural log of 10 divided by the natural log of 2. Remember to put your parentheses in. And we end up with about 3.322 if you go to 2 decimal places. So logarithms allow us to solve problems that have variables in the exponent. So let's try it again. We've got solve 3 to the power of x plus 1 is equal to negative 2. We can't rewrite 2 as a power of 3, so we take the log of each side. And truthfully, it doesn't matter whether you take the natural log or the common log. So let's try this way, taking the common log of both sides. So the log of 3 to the power of x plus 1 is equal to the log of negative 2. Then multiply x plus 1 in the front. We get x plus 1 times the log 3 is equal to the log negative 2. Then divide both sides. It looks like log minus 2, so let me put parentheses. Divide both sides by log 3. I get x plus 1 is equal to log negative 2 divided by log 3, and then subtract 1 from each side. So notice we're setting it all up before we put it in the calculator. That's exactly the last step. So let's just check that we can take log of negative 2. So remember that we can't take logarithm of a negative value. So, oops, we took the log of both sides, which is okay. We've got it all the way down to here. So that you can see that if that wasn't a negative 2, if that was a positive 2, we could solve it. But it turns out, oh, we can't take the log of a negative number. So this has no answer. No solution. Because 3 to any power is never going to get you a negative number. But the process for solving, no answer, because we can't take log of negative 2. All right, so I hope I didn't lead you down the wrong path there. But you can go ahead and you can work it out, but if you got a non-real answer, then that's why. All right, a couple of more examples on solving logarithms or exponential functions using logarithms. The next expression, we have 7e to the 2x minus 5 is equal to 58. So we can't use that trick of taking the log of both sides unless the exponent is isolated. So we have to isolate e to the 2x first. So add 5 to both sides. We end up with 7e to the power of 2x is equal to 58 plus 5, which is 63. Divide both sides by 7. We get e to the 2x is equal to 63 divided by 7, which is 9. Then at this point, now that you have your single exponent equal to 9, now we take the log of both sides. We have base e, so we're going to take the natural log of both sides. Reason, let's see, natural log of e to the power of 2x means multiply 2x in the front times the natural log of e is equal to the natural log of 9. The natural log of e is 1. So we end up with 2x equals the natural log of 9. Divide both sides by 2. We get natural log of 9 divided by 2. That's the exact answer, which is approximately, let me get the calculator, natural log of 9 divided by just 2. And we end up with approximately 1.0986. All right, last example. This is quadratic in form, so you'll run into this a lot in calculus. We're going to solve e to the power of 2x minus 8e to the x plus 7 is equal to 0. Notice this looks a lot like x squared x squared minus 8x plus 7. So this is a quadratic, and we can actually factor it. So it's quadratic in form. That means e to the x goes in the first spot, because e to the x times e to the x is e to the 2x. We want two numbers whose sum is 7, and product is 7, and sum is negative 8. So that's going to be minus 1 minus 7. So e to the x minus 1 times e to the x minus 7 is going to equal this expression. And now we can set each expression equal to 0. So we have e to the x is equal to 1, and e to the x is equal to 7. So at this point, you can rewrite these. These are e to the x, so you can rewrite these as a logarithm. So e to what power is equal to 1? That means natural log of 1 is equal to x. And in this case, the natural log of 1 is 0. E to the x equals 7. You can think of it as taking the natural log of both sides. You'll end up with x is equal to the natural log of 7. So the natural log of 1 is 0, so x equals 0 is one answer, and the natural log of 7 is the other answer. And if you need it decimal, then we type in the calculator natural log of 7. So approximately 1.946.